Okay, so now you're going to get to find out why you've been working so hard on exponents and logs and solving them and all that good stuff. In the real world, y'all, this helps a lot with math of money, meaning like real world interest. And interest is often charged on any kind of a loan that you get or credit card. And also interest can be earned, right? If you invest, and that could be, in the bank or in stocks or something like that. So I'm going to show you sort of how this works in the different types of interest formulas that are out there and how to use them. So we have three categories. We have simple interest, compound interest, or continuous interest. And all of them come from kind of the same basic formula with a little bit of tweaks. Simple interest, your final amount is going to be dictated by what you invest times 1 plus or minus the rate that you're at, the interest rate, raised to the t power, and t stands for time. So the reason there's a plus or minus here is because you could be earning interest, in which case you would add that, or you could be paying interest, in which case you would subtract it, right? So it's whether it's interest is, or your interest rate is increasing or decreasing, or your money's increasing or decreasing. So that's kind of why there's a plus or minus. The compounding interest formula is very similar. Except on this one, when we are compounding interest, we are going to be adding our rate over something called n to the nt power. Now, what does n mean? Well, n means the number of times that you are paying interest or earning interest in 1 year's time. And I'll kind of explain that out below in a second. But in other words, like if you were saying, like if someone's like, hey, I'm going to charge you interest quarterly, then n would be 4 because there's 4 quarters in a year. And then continuous interest is pretty interesting. No pun intended. What continuous interest does is it gives you sort of the ultimate final amount of how much you could make or how much you could be charged. No one in the real world, they're not going to actually charge you continuous interest, and it doesn't mean that they're charging you every second of the day. And you'll see when we do the math. Think of this as sort of like a limit or an end behavior to the amount that is earned or charged. So it's like the absolute highest amount that could come out of something, basically. Real world, though, most of the people use compound interest. Okay, so your A is your final amount after interest. I wish I could just type. I should just type because my handwriting is atrocious. Final amount after interest. Your P is going to be, it stands for principal. But what principal is like your beginning amount. Whatever you're investing, or maybe whatever you have charged on a card or something like that. The rate is, of course, your interest rate, and normally that's given as a percent, but you're going to want to change that to a decimal whenever you plug it into the formula. So make sure you remember to move that decimal place twice 2 units. And then your T, actually let's talk about N first. N is the number of times interest is charged per year. And then T is time measured in years. Okay, so now that we've kind of explained what all the variables are about, we're going to run some problems so that you can sort of see how this is used, and then the differences in those amounts. Okay, so as our first example, well, let me see if I can scroll. Oh, I can. Hallelujah. Woohoo! Okay, so as an example, you know what else I'm going to see is can I type? Because y'all, this handwriting, right? I know you're thinking it because I'm thinking it. Okay, so how about, ooh, it's so small. I'll zoom in just a second. In just a second, happened right now. Okay, so how about you invest $1,200 okay, into an account for, let's say, 5 years. Okay, how much money would be earned based on the following accounts that you have a choice to invest in? So maybe the bank or whoever you're investing with gives you choices, and they're like, okay, I'm going to let you earn 4.6% interest, and maybe they say 4.6 simple interest. Maybe the second option is like 4.4% interest, 4.4% interest, compounded maybe monthly. And then maybe they say like 4.3% interest, compounded weekly. And then maybe they say like 4.2% interest, compounded, continuously. Oops, continuously. Okay, great. Okay, so the thing is, the reason that the interest rate is going down is because this would happen in the real world. The bank is not going to give you the same interest rate and then just change how often they pay you. If they're paying you more frequently, guys, and they're giving you interest more frequently, then they're going to take down the interest rate, because that makes sense. Like, think about business, and they have to make their money too. So you would want to run the math to see which one would be better, let's say after 5 years, and that's exactly what we're going to do. So for case A, we would take this and we would say like, okay, well, I'm investing, if this is simple interest, it's this formula that we wrote down. Oops. A equals P times 1, and I'm going to say plus R to the T, because the thing is, I'm putting interest onto an amount. So we're earning this much money, so I want to add it on. So when I go to fill this in, my A would be equal to 1,200, because that's the amount that I put in, times 1 plus my rate. Well, the rate is 4.6, but don't put 4.6. You need to turn that into a decimal. And back in the 5th grade somewhere, or 6th grade, you learned to move the decimal twice to the left to turn something into a decimal. So it should be 0.046, and then to the t power. Well, the t is just 5. So you're just going to type that in not right now, type that in a bit, and then we'll see what we have. Okay, scenario B. B says 4.4% compounded monthly. So if you're compounding it over different time intervals, that's why we have this formula. And you can go back and read what everything stands for, but if we go to plug in, our principal is still 1,200. That interest rate just changed to 4.4, so it would be 0.044. And then we need to figure out our N, okay? So N means the number of times interest is compounded, or basically paid, in a year. So we are going to be figuring and computing and paying interest monthly, which means how many months in a year? Well, there are 12. So that number is going to go there. It's also going to go up here times your T, which your T was a 5. So we're comparing plans, so we're keeping the same time. The next one, plan C, is compounded weekly. So it's legit almost like the same formula over here. The only thing changing, guys, is the interest rate is now 0.043. And instead of 12 months in a year, there are 52 weeks in a year. And I do hope that you know these numbers. Like if you saw, weekly is 52, monthly is 12, quarterly is 4, yearly would be 1, daily, 365. What's another one you might see? Semi-annually would be 2. So things like that. All right, so we'll type that in just a second and get our answer. And then the last one is continuously. So letter choice D is PERT is the formula. So A is equal to our principal. Oh, I should write that first. No, that's all right. It's PE to the RT power. So 1200 times E, which E is just a number. We've talked about it already. And then the rate is now 0.042 times 5. So this is what you'll be typing in on all these different ones to see what the money would be. So we'll come down here. I'm going to kind of draw a line, and I'm just going to A, B, C, D. I'm going to type everything in from above, and I'm going to put the answers. Hit pause right now, and please do the same so that you can practice typing these in, because when I show my answers down here in a second, if they don't match, you might have an issue. So please hit pause now so the answers won't be spoiled. Okay, so as you can see after typing them all in, letter choice B is the best amount. Now, a couple things before I talk about this. Hopefully you guys rounded it to the hundredths place because we are talking about money. And it would make no sense if you have money that goes out to like 0.58, blah, blah. That'd be dumb, y'all. These are dollars and pennies, so please round it like money. And then we want to, you know, if you're looking for the best account, well, guys, you want the most money, I would think. So I would definitely pick B. B wasn't the highest interest rate, was it? It was not, but we ended up making the most money from it by the way it's been paid out. So there's a balance there between interest rate and how often you're getting paid out. And so it's just smart to know these formulas so you can run your own money and see what it would turn into, okay? So after 5 years, this is how much money you would have. And I think the question originally said, how much money would you earn? So this is actually the final amount in the account. Just be careful because if somebody says, well, how much did you make? We didn't make $1,500, okay? What we made was $1,579.04 minus $1,200 because that's what we originally started with. So if you want to see what your total earnings are on the best account, you would need to subtract that. So minus $1,200. Just to see how much you made. So we actually made $379.04 over 5 years' time, which I know you're like not excited about, but guys, you did nothing for that money. It literally just money sat in the bank or whatever this account was, and after 5 years, you have an extra $380 bucks. So you can see the more money you put in, the more money you would make. The longer you leave it in, the more money you would make. There's all these things that you can play with. Okay. All right. So the next kind of problem, I still want to use our interest formulas, but I want to talk about buying a car because I think these are fun and super applicable, especially for those of y'all who are thinking about buying a car. Now, this formula is not perfect, but it's perfect enough to where you can figure out what kind of a car you can afford. But this formula doesn't take into account that, you know, you are making monthly payments and you're chipping away at your total balance, and that does have an effect on things. But what I want us to do is just to play pretend and do a rough estimate. So we're kind of going to do a rough estimate of how much a car would actually cost us and what our monthly payments would be, okay, based on specific things. So let's do the scenario, right? So let me type this up just like I did a second ago. So we're going to look at you find a car listed at, you know, let's say it's $14,500. And the dealership gives you a rate of, which this is going to be realistic as a first-time car buyer. If you don't have a parent helping you, it's going to be really high. Like, and I say really high, it's going to be higher than this. I'm going to put it at 9%. It's probably going to be more like 11 to 13%, which is wicked high. Your parents can probably go get a car for less than 2% just because they have a credit history. But if you're on your own, babies, you're going to be spending a lot. And you basically are trying to decide how to pay this off. So you are going to be they're going to ask you, you know, do you want to pay this off in 3 years? Do you want to pay this off in 4 years, 5 years, 6 years even? And then I want us to look at our monthly payments as well. Okay, so what I'm going to do is in this box, we're going to figure out sort of how much the final amount of the car would be. And then after that, then we'll look at monthly payments, okay? So let's do that. So basically, if I'm buying a car at $1,400, just so you guys know, cars are compounded monthly. When you buy a car or if you buy a house, your compounding is monthly. But I should have definitely said that. And so for our first one, we'll be typing in the amount of the car, the principal, the $1,500, times 1 plus our rate, which our rate is going to stay at 9%. We're just going to kind of compare the options and keep it at 9%. So 0.0, oh my God, I don't know what just happened. I hit a button and things went crazy. How do I undo this? Control Z, Control Z. Okay, so then we have our rate of 0.09 here over 12, and then to the 12 times 3 power, because we're looking at how much to pay it off in 3 years versus 4, 5, and 6. God bless me. This is going down in history as one of the worst videos I've ever made with all the background noise. Sorry, guys. But it's actually like the most cool, so suck it up because you're going to learn something. JK. All right, so I'm going to type this in and get an amount. So 14,500 times 1 plus 0.09 divided by 12, and that's being raised to the 12 times 3 power. So I'm getting a final amount that if it takes me 3 years to pay off the car, I will end up paying $18,975.36. Which I know you're like, oh shoot, like that's a lot. Okay, yeah, that is a lot. That's called interest. That's how they make their money, right? They have to make something off of you. So if I want to see how much for 4 years, then y'all, all you have to do is change this 3 to a 4. None of the other details are changing. We're just going to take a little longer to pay it off. So if it takes me 4 years instead to pay it off, that's going to be easy to go type back in again real quick. And I'm getting the amount $20,755.38. If I want 5 years, you get the idea. I'm going to hit pause and figure out the 5 and the 6 years. And then I want y'all to take a second to try to figure out what your monthly payment would be. Okay, now what does that mean? Well, shoot, you pay on this every month. So if you have a 3-year note, you're going to need to divide this amount by, well, how many months are in 3 years? Because you're making monthly payments. You're going to divide this by 36 and see what it is. Divide by 36. If it's 4 years, how many months are in 4 years? Well, 48. So you're going to divide it by 48. And that's going to show you a rough estimate of a monthly payment. So try to figure this out all the way out through 6 years. And then once you're finished, hit play. Okay. So this is what I get when I finish it out. In 18 years, holy free holies. In 3 years, the car costs 18 grand, 19 grand. If it takes me 4 years to pay it off, almost 21, 5 years, almost 23, and 6 years, almost 25,000. So when you look at those numbers, most people are like, well, shoot, I want to pay it off in 3 years because, wow, you know, I don't want to pay that much for this car. You know, this $14,000 car that you're looking at thinking, what a great deal, could end up costing you $24,000, $25,000. So it's like, why do people even do it? Well, the monthly payment is why people do it. Because if you want to pay it off in 3 years, it means a higher monthly payment, and that should make sense. So even though it's less money in the end, it's more money each month to pay it off if you get a 3-year loan, okay? And a 4-year loan, it goes down 5, 6. So most people that are, you know, if you're in college and you're working and you're broke, you don't have much of a choice, and you do normally choose this option. I just want you to know what your options are when you guys go in and think about doing that. You know, it's definitely better to make a higher monthly payment, if at all possible, just so in the end you've saved a little bit money and that car hasn't cost you your life savings, okay? Now, I know this video is longer than my normal, but I have one more thing to do, and that's basically working backwards for time and for principal. So what if you have a question that looks like the following? So maybe it's like, okay, you invest, you know, how about, let's invest like $2,500. You invest $2,500 in an account compounded let's do continuously for fun. At a rate of, I don't know, how about like 7.2%? How long will it take you to triple your money? All right, so if we're following the format of the equation for continuous interest, we're up against A equals P to the ERT power. So let's fill in what we know. Well, we know we're investing $2,500. Okay, E is just a number. We know the rate. We know the rate is 7.2%, so that should be a 0.07. What we don't know is the time, because it literally says how long. So the T is unknown, and it wants us to triple our money. Well, what is $2,500 tripled, right? Well, 2,500 times 3 is $7,500. So this is the problem we're solving. So now instead of just typing all this in, we need to do a little bit of math. So luckily, we know how to solve exponential equations. Let's divide the 2,500 off of both sides. When we do that, we'll get 3 equals e to the 0.072 t power. Well, we're trying to solve, which means, we need to isolate the t, but it's stuck in the exponent, and you might feel like you are stuck. So this is when you can rewrite things as a log, right? So if I want to rewrite it as a log, the base is e, right? Log base e, but log base e is the same thing as natural log. And remember, when you rewrite as a log, everybody kind of switches places. So this is going to turn into the natural log of 3 equals 0.072 times t. Look at your conversion formula for exponents to log if that doesn't make sense to you, because it's supposed to be something like this that you can go back and forth on. Okay, and that's literally all I did just now. Now I'm going to use my calculator, because if I'm solving for t, I want to divide off the 0.072. And once I type that in, I will get what my money, or not my money, I'm doing time right now. So it's going to be how long it takes me to make this happen. So it looks like I'm getting 15.3-ish years. Which, yeah, that's a long time, but if you have money to put away and just kind of forget about it, then, in 15 years, maybe after college, after getting a job, after getting hitched, maybe you got a kid, then you go, oh my God, we put money in the bank, and then you go look and it's tripled. So that's kind of what you're learning here. So that's how to find or solve if there's an unknown time. You could also do, maybe the principal was unknown. So what if it was a question of like, what if you know that you want 10 grand, okay, in 10 years, and you have an interest rate that's been given to you of like, 5.4% or something like that. Then you're asking yourself, like, how much should I invest, okay? So this is a good question for, like, let's say you're saving up for a car that you want to pay off, like you just want to pay up right for it. Or maybe it's a down payment for a house that you want to have that much cash, and you're like, well, shoot, how much could I put in the bank and forget about for 10 years so that I have that money when I need it, right? So how much should I invest? Okay. Well, I want to have 10,000 at the end of the day, so that is my A. I don't know how this is being compounded, but I will say if this is a normal bank account, a lot of those are only going to pay you quarterly, just FYI. You'll get a statement every 3 months. They're only paying you quarterly. So if they're paying me quarterly, I'm going to use the compounding interest formula. I don't know what my P is. That's what this question's about. How much should I invest? 1 plus my interest rate, 0.054, over N. So N is how many times per year. This says quarterly. I need a 4. And then 4 times 10. Why 10? Because I said I could afford to leave it in for 10 years. So now I need to solve this. So if you're trying to solve for P, don't panic that there's a bunch of junk behind it. You're just trying to isolate P. So guys, if you divide off all of that junk, then we can type this in one big fail swoop right here. I'm going to go ahead and write that as a 40 because, whatever. So you divide that off of both sides. Now we're going to know how much we should have initially invested. So 10,000, I'm typing in, hopefully you're typing in with me, divided by 1 plus 0.054 divided by 4, and that is being raised to the 40th power. So I am getting $5,848. Whoa, there's a lot of comments going on there. What is happening with me today? Silly lady. $5,848.57. So if I put that in the bank today and forgot about it for 10 years, then in 10 years I could have a down payment for a house. A little nest egg. All right, hopefully you learned a little something about interest and how to use those formulas and how to solve for different things. And if not, I'm sure there are so many other people on the internet that can help you in different videos. But I really do hope that this video did the trick for you. I know it was 25 minutes, which is kind of long. I apologize, but probably better than me standing in front of you and telling all kinds of stories about trouble I've gotten into with money in the past. And taking your entire 90 minutes to do the same amount of work. All right, good luck, guys. Have fun figuring out money stuff.